you take two alias from table employee and you join on manager ID, employee ID. But sometimes you can join with different names of manager ID and employee ID. But there is something important you should keep in your mind here, that is that the manager ID should have the same type as ID. So here int, it should be int. Float should be float. String should be string. Date should be date. So it doesn't make sense the names, but the most important is the what is the type. So if you go to manager ID and employee ID, you will find them of same type. Let's check. Employee manager. This is the employee ID here. It's integer. And manager ID is also an integer, right? Here the manager and no, here the man here sorry, the manager is not an employee. Yes, it is. And the manager ID, it's in the before the last one. So before the last one, this is the manager. You see here the manager ID also in the departments. Let's check. Yes, it's in the departments manager ID. So it is integers, and here it's integers. Okay, so they are equal, but they are not the same. Employee ID, manager ID. So we are doing inner join on that in their type, not on their really names. Okay, so we don't care about the what's important finally is to check if this value equal to this value. This value is equal to this value. Okay, this is the most important. This is why we don't care too much about the names, but we should care about the types. Okay, now we're done. We just do equals. Now left join, outer join, table 1 left outer join table 2, and you should say here on table 1 dot column name the same, table 2 column name, write the same on table 1 dot column name, table 2 dot column name, you calculate. This is we learn in linear in relational algebra how to calculate. This is an example to understand all of this. For example, we want to use left outer join. How we can express about or left outer join? We want last name and department name, last name and department names of all employees. So let's check now here. We want department, last name and department name of all employees. This is the employees. We have last name in employees, and we have also department. We don't have department name or department ID. Department name of all employees. Do we have the last name? We have in employees, but we don't have department name. So the department name is in the departments, right? Here. So we want from two different tables, one attribute from the first and second attribute from the second. So from employee, we want last name, and from departments, we have department name. So we should do join. how we can do join, on what we should do join in department ID, because department ID here is also exist in the department, in the employee table as department ID. We have also manager ID, but manager, no, we can't do here join on manager because we need one primary and second foreign. Okay. Okay. This primary should be linked to this one here. So this relation one to many. Okay. It means that when you find a foreign key within a table, it means that the employees, many employees can be members of one single department. So if we have here, you may find in a single department, department 100, ID, department ID equal 100, you can find several employees work in this department 100. So the table that has the foreign key, it has many employees work in one department. This is the concept of primary key and foreign key. Who has foreign key is the N, and who has the primary key is 1. So this relation between departments and employees is 1 to many. So many employees can work within the department ID 100. Okay? And here, as you see, for example, to explain to you or to remind you, country ID is primary, where country ID as a foreign key in locations. What does this mean? The relation between countries and locations is 1 to many, which means that many locations many locations are belonging to the same country ID, and this is normal. As I told you, locations, for example, Sur are in country ID is Lebanon. So Sur under Lebanon, Saida under Lebanon, Jbail under Lebanon, Beirut under Lebanon, Tripoli under Lebanon. You see, this is 1 to many. So many locations are belonging to the same country ID. Let's come back to our example. To our example here, we want last name and department name of all employees, even those who don't belong to a department. So we want from department name, and from employees, we want last name. So this is why we should use a join between this and this. But also he said to me, we want also all employees, even those who don't belong to department. What does this mean? Don't belong to department. What does this mean? Who doesn't belong to all employees. We want department name, we want last name of employees, and employees that doesn't belong to department. This is it means that we should take from the we should take the employees that they don't have, they are not related to department ID, because he said even those who don't belong to a department, they don't belong to a department. So they don't belong to a department. It means that the department ID here as if it's null. Right? What does this mean? It means that who doesn't belong to department. So here we should take department ID, the employees also for department ID. Department ID is null. So this is why we should do left join. Why left join? Because look, we should join the primary with that foreign, right? But we should take all departments here that also don't have values here, null. So what he did, let's check. Select last name, department name from employees E. Look, he started with employees, the relation of many. E, left outer join. Remember, left outer join, you should take the attributes that doesn't contribute to the join with the departments. Let's get back to the relational algebra, I think, here, for example. Look what's the left outer join. You have relation A and S, and we are doing left outer join in A when it's equal to D. So R dot A is equal to S dot D. Look what's the left join. Left outer join, you take the first line, you check A equal D because you are doing AD. A here 10 equal 10, yes. So you concatenate this to this and you add them here. So 10, 5, 120, ABCD, 10, 5, 120. We joined them, we وصلناهم, we link them together. ABCD, okay? Then you check 10 equal 10 here, no. 10 here equal 10 here, no. We are done from 10. You get to 20. 20 equal 10 here, no. You don't add. 20 equal 20, yes. So you add 26, 1 to 20, you join them. 26 to 20, you join them. Now 20 equal to 40, no, it's not. So you get into 30. 30 equal 10, no. 30 equal 20, no. 30 equal 40, no. So left outer join, you should take from the left table the rows that do not share to this joins. Who is 34? So 34 exists in the left table, right? Left hand side table in R, and didn't contribute to any join. So it doesn't add join with other tables. So you should take it. This actually, what does this mean?